Hi there, and welcome back to another Papetti Math YouTube video tutorial, where today I am going to be teaching you, yes you, Algebra 1. And in this video, we're going to be looking at exercise number 3 in our lesson on GCF factoring. And it says, for each of the polynomials below, factor out the greatest common factor. Your final answer should be expressed as the product of the GCF and the remaining terms. So we're always going to write our GCF times whatever remains after we divide the GCF out of it. So let's take a look at part A and think to yourself what the GCF of part A is. And before each one of these exercises, if you want to pause the video to think of the GCF on your own first, that would be helpful as well. So in part A, our GCF is going to be 7, because 7 is the largest number or variable or product of number and variables that could divide evenly into all of these terms. So once again, since our GCF is 7, we're going to divide that 7 out of all of our terms. 14x squared divided by 7 is going to give us a quotient of 2x squared. 21x divided by 7 is going to give us a quotient of 3x. And negative 7 divided by 7 is going to give us a quotient of negative 1. So our factorization here is 7 times 2x squared plus 3x minus 1. In part B, we look for our GCF, and again, they don't all have x's, so the GCF is going to just be a constant, and our constant GCF is going to be 3. 3 is the largest number that could be divided by all of these terms evenly. So what's going to be left over now? And the way we find that is we divide each of these terms by the GCF. Now we have 18x squared divided by 3, and that's going to give us 6x squared. Negative 12x divided by 3 will give us negative 4x, and 9 divided by 3 will give us positive 3. So our factorization here is going to be 3 times 6x squared minus 4x plus 3. Let's take a look at part C. Now we're going to bring in a GCF that's not only a constant, but also has variables in it as well. So let's just look at our constants first. And our GCF of 12, 10, and 20 is 2. But now, what's the most amount of x's they all have in common? And if they all have 4, 3, and 2, if each term has 4, 3, and 2 x's, what's the most that they all have? And the answer is the lowest number of x's. So they all have at least an x squared. So now that I know that my GCF is 2x squared, I could go ahead and I can divide out 2x squared from each of these terms. And let's see what I will be left with in my factorization. I'm going to have 12x to the fourth divided by 2x squared. That's going to give me 6x to the second. I'm going to have 10x to the third divided by 2x squared, and that's going to give me 5x. And finally, 20x squared divided by 2x squared. Well, the x squareds cancel out, and I'm left with just 10. So my factorization here is 2x squared times 6x squared plus 5x plus 10. All right, let's go to part D. And in part D, now we're just looking at a binomial, and that binomial is 45x squared minus 25. So again, we look for our GCF. They don't both have x's in them, so the GCF is only going to be a constant. And that constant GCF is going to be 5, because no other number larger than 5 can be divided evenly into 45 and 25. So now divide both of these terms by 5, and 45x squared divided by 5 is going to give me a quotient of 9x squared, and negative 25 divided by 5 will give me a quotient of negative 5. So my factorization in part D is 5 times 9x squared minus 5. Let's take a look at part E now. And now this one's a little tricky, and that's because you might look at 27 and 54 and think that the GCF is 9. But there's a larger number than 9 that does go into 27 and 54, because 27 times 2 will give you 54. So my GCF is 27, and then we look at our x terms, and they both have x's on them. And what's the most amount that they both have? And the answer is x to the third. So they both have at least a 27x to the third, which means that's what we're going to divide each term by, 27x to the third, to see what remains inside these parentheses. 27 divided by 27 is 1, so they cancel out. And x to the fourth divided by x to the third is just x. Negative 54 divided by 27 is negative 2. And x to the third divided by x to the third is 1, so they cancel out. So we're left with just that x minus 2. So our factorization in part E is 27x to the third times x minus 2. And now finally in part F, we have 28x to the fourth minus 40x to the third plus 8x. So the first thing we want to do is find the GCF of our coefficients. And the GCF of our coefficients is 4. And they all have at least one x in common. So my GCF of this entire expression is 4x. Now the way I get what remains inside my parentheses is I'm going to divide each term by 4x. And when I do so, I'm going to be left with 28x to the fourth divided by 4x will give me a quotient of 7x to the third. Negative 40x to the third divided by 4x will give me negative 10x to the second. And 8x divided by 4x is going to be just 2. So my final factorization here after I factor out my GCF is 4x times 7x to the third minus 10x squared plus 2. So here in exercise number 3, we factored out a GCF from 6 different parts in this exercise. And if this video was helpful, please give it a thumbs up, and you're now ready for exercise number 4. Thank you for watching.